All right, good morning and welcome to your daily dose of calculus. You're going to need your own paper for notes today. You should also have calculator out for sure. I've only got this old one today, and you might want to grab this sheet. Also, I'm going to do a little review for your integrals quiz, which is tomorrow, and I'm going to do some of the questions on this with you and talk about some others. So pause this video while you get your paper out and get this out, and when you're ready to begin, we'll start with the new notes. Okay, so we've been talking about volume for a couple days now. So this is day 87, and you can call this even more disk method. And quiz review. Okay, so basically what we're doing today is just some more examples with revolving regions around X or Y axis. Some of them are going to be a little trickier than the ones you've done up to this point, but same ideas that you've seen the last couple days. So we'll start with number one. Number one is revolve the region bounded by x equals y squared y equals -2 and y equals 2 about the y-axis. Find the volume. All right, so the first thing we definitely need to do is sketch a graph, see what this looks like. And again, when it's got the y as the independent variable, it's a little trickier to graph. So for my own self, I kind of need to make a table. You might know what this one looks like. It's just a sideways parabola. It's open to the right because it's positive y squared. But you pick some values for y, like let's say if y was 0, what would x be? 0. If y was 1, what would x be? Y squared, you get 1. You get the same with -1. X is 1. I mean, if you picked y equals 2, you'd get x equals 4, etc. So I think that's probably enough to give you a decent looking graph. We've got 0, 0. We've got 1, 1. We've got 1, -1. We've got 4, 2. You would also have 4, -2. Plug -2 in for y, so you're definitely going to get that sideways looking parabola. So it says it's bounded by that y equals -2, so that's this line down here, and y equals 2, which would be up here. So when they're talking about the region bounded by those three graphs, we've kind of got a couple of regions. We've got this one, and we've got this one. But since that's a complete region from -2 to 2 on the y-axis, we don't have to split this up. Now remember, if I'm revolving it about the y-axis, I'm going to get a symmetric shape on this side. And whatever axis I'm revolving around, I need to make my rectangle perpendicular to that axis. So when I revolve it, it's going to look something like that. But the important thing is, since the rectangle is horizontal, this height or this width of this rectangle would be a y distance. So we're going to have to do everything in terms of dy, which is good because that's what the graphs are set up for already anyways. Okay, so make your equation. Volume's going to equal what always goes out front, pi times the integral of, what are your limits? We're doing y's, so it's going to be -2 to 2. And the width of all of these rectangles, or the radius of all these disks, I guess I should be saying, is going to just be y squared. That's pi r squared h. H is dy. So there's your formula. All right, so we can clean this up a little bit. We have pi times the integral from -2 to 2 of y to the 4th dy. Now remember, if you don't want to plug in -2 and 2, this is a symmetrical situation again. So what the book would do, and what you might want to do if you're a little algebra deficient, is to say that if I take double the integral from 0 to 2, I'll get the same thing. It's up to you. You don't have to do that. You can still just do pi times the integral from -2 to 2 also, but this just makes the algebra a little bit easier. Okay, so now we have the volume is going to equal 2 pi times y to the 4th becomes y to the 5th over 5, evaluated from 0 to 2. So volume is going to equal 2 pi times 2 to the 5th over 5 minus 0. And 2 to the 5th is 32, so 2 pi times 32 over 5 is going to end us up with 64 pi over 5. And again, you'd get the same thing if you had done the -2 to 2 thing as well. All right, any questions? Well, if you do, pause the video and rewind it and watch again. Okay, here's number 2. Revolve the region. Bounded by y equals x over 2. Y equals 2. And x equals 0. About the y-axis. Find the volume. Okay, so as always, what's our first step going to be? Draw it out. All right, so I've got y equals 2. Let's do that one first because that's easy. We've got x equals 0. So that's the y-axis here. And y equals x over 2. So if you think of that as y equals mx plus b, the y-intercept is going to be 0. The slope is 1/2, because that's like 1 over 2x. So up 1 over 2, up 1 over 2, and give us something that looks like this. That's y equals x over 2. And we're looking to revolve that region that's bounded by those. So this is the region that's bounded. We're going to revolve that around the y-axis. Okay, so if I'm revolving around the y-axis, then that region is going to have a symmetrical region over here. Representative rectangle has to go which way if we're revolving around the y-axis? It's got to be horizontal, because it's always perpendicular to your axis of revolution. So if I revolve that, I get a disk. And the issue is, does this have to be a dx or a dy? Well, since it's a horizontal rectangle, that width is a y distance, so that's a dy, so everything needs to be in terms of y. Is everything in terms of y? No. We've got this problem here, y equals x over 2. So I need to solve that. We have y equals x over 2, but if I'm going to do dy, I need it to be an x equals equation. So this is the same as x equals 2y. So think of this as x equals 2y. Okay, now I think we're ready to make our equation. So it's a disk, so volume is going to equal pi r squared h. So pi times the integral from what to what? It's y values, so this region is bounded by 0 to 2, of r squared, so the radius of this disk would be whatever 2y is, so it's going to be 2y squared and dy. Okay, let's evaluate pi times the integral from 0 to 2. That's really 4y squared. Make sure you square both pieces there, dy. So volume is going to equal pi times 4y squared becomes 4y cubed over 3, evaluated from 0 to 2. So the volume is equal to pi times, plug in 2, we're going to have 4 times 2 cubed over 3. Plug in 0, it's just going to be 0. 2 cubed is 8. 8 times 4 is 32 over 3. So 32 pi over 3. All right, so the important thing with that one is just to remember that make sure your variables are agreeing. So right now, if we're perpendicular to the y-axis, we're dy, and that means we need to be in terms of y, which sometimes we have to manipulate our equations a little bit. All right, I got 2 more before quiz review. So here is number 3. Revolve the region. Bounded by y equals negative x squared plus 4x minus 2, and y equals 1 about the line y equals 1. Find the volume. Okay, so just reading about this, something should look different to you. What looks different? Well, first off, the equation is a little bit harder to draw, so we'll use our calculator for that part. But the big thing is we're revolving it about the line y equals 1. We're not revolving around the x-axis, we're not revolving around the y-axis. So that's going to change things slightly. But let's draw it out anyways. So I know what y equals 1 looks like. That's this. And that's also our axis of rotation now. Oops. Just kidding. Okay, so let's see what this graph looks like. I'm going to plug in, even though I know what y equals 1 looks like. I'm just going to put that in so I have a reference point. The other graph is negative x squared plus 4x minus 2. And let's zoom standard that. There's y equals 1. There's my graph. Okay, so it's going to look something like this. So that's definitely the region I'm going to be revolving. So if I'm revolving about the line y equals 1, there's my representative rectangle. And revolving it about that is going to make an opposite symmetrical piece, like always. There's your disk. So already, are we going to be dx or dy? Well, the width of that rectangle is horizontal, so that's a dx. We're definitely doing dx. We want everything in terms of x, which it is, so that's good. But it's a couple tricky things. First off, my bounds of integration, I don't know right now. The bounds are whatever this is to this is. So what do I need to do first? I've got to find the intersections. Okay, so let's do second calc intersect. First curve, second curve, guess. Okay, we got 1, 1 over here. Then I got to do the same thing on the other side. So second calc, intersect, first curve, second curve. We got to guess over to here and a little bit further. Okay, the second one is 3, 1. All right, so now I know that my volume is going to be pi times the integral from what to what. We're in terms of x's, so we care about our x coordinates, 1 to 3. Pi r squared h, so we need the radius of that disk squared, and then h is the dx. But this is tricky. What goes here? It's not just this squared, because think about what I'm looking for. I want this distance. That's the radius of the disk. If I put negative x squared plus 4x minus 2, that's this entire distance. So how do I get just this distance right here? Okay, well, think about it. If I take this entire black distance and take off this part of it, what's that distance? Well, if that's y equals 1, that distance has to be 1. So it turns out that the radius that I need here is the entire black distance, which was whatever that function is, negative x squared plus 4x minus 2 minus 1, because I have to take off that portion of it. Okay, so when I go over here, I'm going to put this inside for my radius. So I need a little more room. Let's call this r for now. So volume is pi times the integral from negative 1 pi times the integral from 1 to 3 of that radius, so negative x squared plus 4x would be minus 3 squared dx. And if you definitely could do this by hand, it's not u sub because there's no extra piece after you take, if you let u equal this, you wouldn't have a derivative. But I could square this out, get what that actually is, and take each piece individually. So it's definitely doable by hand. But since you're mostly lazy people, we'll just do it this way. It's going to be math 9. This is the old calculator, so it starts with, oops, I need a parenthesis here, negative x squared plus 4x minus 3, all that squared, comma x, comma 1, comma 3, and what do we get? Does that math fract anything nice? It sure does, 16/15. So the volume is pi times 16/15, which means my answer is 16 pi over 15. Okay, so again, the real tricky part with that one is definitely this idea that the radius isn't just the function. So you got to actually remember what you're doing here is you're trying to find the radius of that disk that you're revolving. So be careful with ones like that. Okay, last one before some quiz review. Number 4. Revolve the region. Bounded by x equals y squared and x equals 4 about the line x equals 4. Find the volume. Okay, so as usual, we're going to start with our graph. And I've got x equals y squared. We did that earlier today. We know that's going to have 0, 0, 1, 1, and 1, negative 1. We're going to have 2, 4, and 2, negative 4. Just kidding. We're not going to have that at all. Sorry about that. That's why I always make my table. So we're going to have, when I plug in 0 for y, I get 0 for x. If I plug in 1 for y, I get 1 for x. If I plug in -1 for y, I also get 1 for x. If I plug in 2 for y, I'm going to get 4 for x. So that means it's actually 4, 2 that's on the graph. And if I plug in -2 for y, I also get 4 for x. So 4, -2. There's a better picture. That's x equals y squared. And x equals 4. So that would be this line right here. So there's the region. We're revolving it around the line x equals 4. So I'm revolving it this way. So here's my representative rectangle perpendicular to the axis of rotation, in this case x equals 4. There's your disk that gets revolved when that rectangle goes around. So do I need dx or dy? It's the first decision. Good, dy. Limits of integration are y values. So we're going from a y value of -2 to 2. So I can say volume equals pi times the integral from -2 to 2. I need the radius of this disk. So think about how you'd get that. This whole distance would be what? 4. I want to subtract off this piece of it, and that piece of it would be what? That's that y squared. So this time I gotta take my radius as the whole distance, 4, minus this smaller piece, which is minus y squared. So the radius is 4 minus y squared, dy. So it really helps, I think, to draw it out like this and see what you're dealing with. If I want that chunk left, it's part of that bigger chunk 4 minus the smaller chunk, which is whatever the function is, y squared. Okay, so again, you could square this out. We could definitely do that by hand. Let's use Math 9 instead. So Math 9 is, it's going to be 4 minus, we can't use x, so y, or can't use y, so x squared, comma x, comma -2, comma 2. If I was doing it by hand, I probably would do my double 0 to 2 trick. But this comes out to be, math frac, 512 over 15. So volume is pi times 512 over 15. Don't forget that pi in your answer. 512 pi over 15. All right. So there's the new notes for today. As far as new homework assigned, you can now do problem sets 82 and 83. But those won't be due until next week. So remember, when you're bored on your day off today, you can definitely be doing the homework that's due tomorrow, because this week you still have problem sets. I believe it's 78 through 81. I think there's 4 of them. So that's due tomorrow. You can also be working on your take-home test. Take-home number 7, which I handed out yesterday. That's due next Thursday. But probably what's more pressing and more important right now is some quiz review, because you do have that quiz tomorrow. So let me talk real quick about the quiz, and then we'll do a couple questions on that review sheet. Okay, so the format of the quiz, we got 14 multiple choice questions. There's 7 non-calculator questions. What you should expect in the non-calculator questions: ton of integrals. And integrals could be indefinite integrals. That's when there's no bounds. So if there's no bounds, what do you need on the end? Plus c. Could be definite integrals where you have bounds. And there's some that are u sub. But be careful, they're not all U sub. So make sure you don't just try to U sub everything. You don't always need U sub. You only use U sub in certain cases. And we'll talk about that in the review sheet in a second. Other thing on the non-calculator section, there's some fundamental theorem of calculus questions. Remember, there's two parts to that. Part one is when you're taking the derivative of an integral. So if taking the derivative of an integral with a constant down here to some x value or a function f of x up there, let's say it was just t dt. Then remember what you do. You plug that function, maybe it's just x, maybe it's more than that, into whatever equations in that integral. So plug in f of x. Then you have to multiply by the derivative of whatever's up top there too, because of chain rule. So those are usually quick, easy questions. Don't miss those. Part two of the fundamental theorem you use when you're integrating, because part two is just doing definite integrals by hand, which you'll definitely be doing since you don't have a calculator on this part. So that's when you have the integral from a to b of f of x dx. You have to find the antiderivative. Big F is antiderivative, evaluated from a to b. So you take your antiderivative, plug in b, and subtract your antiderivative, plugging in a. Okay, so that's the non-calculator section. On the calculator portion, you're going to have 7 calculator multiple choice also. There'll still be some integrals. Some of those you can just plug right into your calculator, but there also could be some ones with variables in it that you got to do some thinking with that your calculator might not help you with. And this is where I'm going to put stuff about area between two curves. That's what we did earlier this week. If it's in terms of x, so if your equations are in terms of x, then the area would be the integral from a to b of the top curve minus the bottom curve dx. And there's a lot of those. I think it was problem set 80 or 81, one of those two. You should definitely do those because that'll help a lot with that. But if the area is in terms of y, then area is going to equal integral from y values, c to d. And instead of top minus bottom, what do? We do right minus left. And that's in terms of dy. Okay, so some tips with your multiple choice. Use the multiple choice. There's definitely some questions on there where the answer you get might not match the multiple choice, but use the answers, see if you can match them up with your calculator, or see if you can guess and check to your answers with what you have. That'll help on a couple questions. Another thing to remember, with area, you're going to have to find intersections sometimes. So if they crisscross, make sure you know where they crisscross and how you deal with that. We'll talk about that in the review sheet in a second. Some general calculus things. Remember that if something is continuous, does continuous imply that it's differentiable? Just because something's continuous, is it always differentiable? Are you always able to take the derivative? And the answer is def not. What's the obvious answer that disproves that? This guy right here. He's continuous, but he's not differentiable. So just because something's continuous does not mean it's differentiable. What about the other way? If it's differentiable, does it imply that it's continuous? If you're able to take the derivative, does it have to be continuous? Yes, that's true. If it's discontinuous, then the way I can take the derivative where something doesn't exist, and if there's a hole, I can't take the derivative of that piece. What's the slope of a point? Doesn't make sense. It's got to be part of a larger thing. So yes, if it's differentiable, it is continuous. But be careful that you know the other way is not true. Okay, well, to finish off, I'm just going to go over a couple questions that I think would be good review questions on here. If you just want to try them on your own and watch the video later if you need help, feel free. But I've got a couple picked out that I definitely want to talk about. So the first one I'm going to do is some integration. So what I mentioned a second ago, not everything's U sub. Look at A through E here. Which ones are U sub? C, D, and E. B is not U sub, because if I set U equal to this inner piece, the derivative of U would not just be dx. This one, the derivative of U is just a constant, so I can deal with that. That's why it's U sub. Same here, the derivative of U is a constant, so I can deal with that. Here, the derivative of x squared plus 3 is going to have an x in it, so I can deal with that. So these are U sub, these are not. So how would you do A and B? Well, A, everything's divided by x cubed. So you got to start by dividing each piece by it. So think of this as the same as the integral of x to the 4th over x cubed, which is just going to be x to the 6th over x cubed, which would be x cubed, and x cubed over x cubed, which would be 1. Now that should be a soup ease integral to take. This is going to be x squared over 2 plus x to the 4th over 4 plus x, and what do you need at the end? Plus c, because it's an indefinite integral. All right, so with B, if this isn't U sub, what can you do? Really, the only other option is multiply it out. So think about taking x plus radical x times x plus radical x. We're going to have x squared, x radical x. This is also x radical x. And radical x times radical x is x. So over here, this is the same as the integral of x squared. X radical x plus x radical x is 2x radical x plus x dx. Now we can almost integrate this now, but this guy is kind of annoying. So we want to think of him as 2x times x to the 1/2. That'd be the same as 2x to the, add the exponents, 3/2. So now I just need to find the integral of x squared plus 2x to the 3/2 plus x dx. Now it should be fairly soup ease. X squared becomes x cubed over 3. 2x to the 3/2 is going to be plus 2x to the, add 1, 5/2 over 5/2, or times 2/5 plus x squared over 2 plus c. Okay, so then finally clean that up. We're going to have x cubed over 3. Multiply all that in the middle. We have plus 4/5 x to the 5/2 plus x squared over 2 plus c. So that one's a little bit ugly, but that's how you deal with it. So if you can't U sub, just multiply it out. All right, so C, D, and E again are U sub. If you need help with those, look at the answer key. I also wanted to talk about, let's look at 2b here. 2b, find the derivative of an integral. How do you do that? Well, since the bottom's a constant, all I have to do is take that upper piece, plug it in wherever there's a t. So 3 times 5x squared plus 2 times 5x. But since that's not just an x up here, it's 5x, what do I also have to multiply it by? The derivative of 5x, which is 5. So cleaning this up, this would be 25x squared times 3. So we have 75x squared plus 10x, all of that times 5. 75 times 5 is 375x squared plus 50x. So that's that fundamental theorem part 1. Don't forget how to do those. All right, 3a is a little weird. If f of x is this piecewise function, find the value of the integral from -1 to 2 of x times f of x dx. All right, well, since I have two different equations for this interval, I've got to break this up. we would have the integral from -1 to 0 of that x is the trick, don't forget that, x times, if I'm between -1 and 0, I'm using the top equation, so 2x minus 1 dx plus the integral from 0 to 2 to finish off that distance of, again, the x is here, so x times f of x, which is x squared dx. So I'm going to have to find this integral, -1 to 0 of 2x squared minus x dx plus this integral, 0 to 2 of x cubed dx. And I'll let you do that, but the setup with the piecewise function, and also watch out if there's anything inside here. All right, the last one I'm just going to talk about real quick. The back is all area. So if you look at the very last question, or the directions here are find the area between the graphs of y equals this thing and y equals this thing. It says solve with your graphing calculator and fn int. So with all the area questions, the first thing you really have to do is look at a graph, because you're not going to know what it actually looks like and which is the top curve and which is the bottom curve. So if I throw in x cubed minus 2x squared plus x minus 1 in y1 and negative x squared plus 3x minus 1 in y2, let's look at what we got here. We've got a cubic and we've got a parabola. Now it's hard to see what's happening here. Let's zoom in a little bit. Let's make our window from maybe -4 to 4. Is that enough? I didn't do 4. Hang on. -4 to 4. See if this looks any better. We've got that, and then we've got that. So there's two regions. There's this piece here and this piece here. Let's even shrink our y a little bit. Let's go from -5 to 5. We should be able to see that even better. Okay, so that region and that region. So draw that the best you can. You know, my drawings aren't always great, so no judgment here. It's going to look like this and something like this. So we're going to have to find a bunch of intersection points. We got to find intersections of this region and this region. So second calc intersect, first curve, second curve, guess. 0, -1 is the first one. So right here is 0, -1. Do it again. Second calc intersect, first curve, second curve. Let's go this way. That is -1, -5. And then finally this one up top. Gotta get all the way up there. It's gonna take a while. So much clicking. Okay, we get to here and we see 2, 1. So when I do this first region, area is going to equal integral from x values, because we're in terms of x, so -1 to 0. What's the top curve here? We'll follow it along. This top curve is the cubic. So it's going to be x cubed minus 2x squared plus x minus 1 dx. Oops, got a little excited there. Top curve minus the bottom curve, that's the parabola. So that minus -x squared plus 3x minus 1 dx. Plus, I got to add this area. So plus the integral from x values again, 0 to 2 here. Now the top curve is the parabola. So -x squared plus 3x minus 1 minus the bottom curve is the cubic. x cubed minus 2x squared minus x minus 1 dx. And then you could clean both of those up if you wanted to. So you could distribute, combine like terms, distribute, combine like terms, clean it up, make it look a little bit better. But that's how you'd have to do a problem like this. All right. So today I would really spend a lot of time on your problem sets if you haven't yet, especially the area problem set, because that's definitely going to be on the test tomorrow. And then do this review sheet, use the answer key. If you have questions, feel free to email me. I'll be checking throughout the day. But hope you have a great calculus-filled day.